Welcome back. This is the third lesson recording for IM1, April 20th, 2021. Okay, so we've used the tracing paper to rotate this figure 90 degrees clockwise around the origin. Is there a way to do this without the tracing paper? Well, there is. It's a little bit more complicated, but let's see if you can figure it out. So I'm going to erase this and let's try to do it without the tracing paper. But before I do that, I am going to show you something first. Okay, so let's say if you wanted to rotate just a point. Let's just say that point was right here. Okay, what we can do is we can draw a line to the center of rotation. Now if I wanted to rotate this 90 degrees clockwise, again I put my pencil here on the rotation, and this is going to be where it's going to be, right? 90 degrees is here. If I wanted to rotate it 180 degrees, it will be here. And you can kind of picture where the point will be corresponding to. If I was rotating that point here, the point would correspond to this. It's the same idea without the tracing paper. So if I want to rotate this, what you can do is you can draw a line to represent that point. In this case, from the center, I am going to follow the grid line. So I am going to draw this line looking like this. Okay, so I am drawing my L to the vertex here. Now, don't worry about the image. Can you just try to rotate this L? If I rotate it 90 degrees, then this part is going to be, instead of going up, it's going to be going across by 2. And then from here, it's going to go to the left. But just try to picture it. You can always rotate your picture, and then it's going to go up by 1, 2, 3. So it's going to be going up by 1, 2, 3, because here it went up by 2. So instead it went to the right by 2, and it made a left turn from that point and went 3. So it went to the right and then took a left turn and went up by 3. So this point corresponds to this point. Okay, now we can do the same thing with all the other points. Okay, so draw a L from the point of origin, rotation, center of rotation. So this time I am going to draw L that looks like this. Okay, so that means if I rotate this part, it's going to be 1 to the right, but then I am going to go 1, 2, 4, 5 up. So here I went up by 1 and took a left turn and went 5. So instead, when I rotate this part 90 degrees, I'm going to end up here. And then from here, I am going to sort of pretend that this way I'm going to take a left turn and go up by 5. So, and if I go up by 5, 1, 2, 3, 4, 5, it's going to be right here. So this is my new point right here as well. That just corresponds to this point here. And you keep doing that with each of the points. Okay, so this vertex here is, I am going to go up by 4, and then take a left turn by 3. So instead, if I just rotate this bar here, it's going to be going to the right by 4. And then from here, I'm going to take a left turn. Left turn means it's going up by 3. It's going to end up here. And I keep doing that, and then I can find all the vertices of this shape, and indeed I can trace this shape to be this precisely. And after you have done so, done the rotation, it's very, very important that you look to see, do the two shapes look the same? And they should be the same. That's the nature of transformation. The shape needs to be the same, the size needs to be the same. It's just the orientation and the location that changes. Okay, so that's just a quick extension. Now we're going to be talking about notation of transformations. Now, first thing, I want you to tell me what are the 3 transformations that we've learned so far. Well, we've learned the translation. Okay, what is a translation? Translation moves the image or the shape left to right. There's a left or right shift or up and down shift. Any combination of any of them, right? So if I have this original triangle, the light blue becoming the dark blue, the light blue triangle started off here and it moved 2 units right and then 2 units down. Okay, it can be any number. It can go 2 units right or 3 units left, or it can be any left or right number and any left and right number, and it doesn't even have to be a whole number. Okay, how do I know that which was the original, which is the final after transformation? It's with this prime notation. Okay, so A went to A prime tells me A is the original, A prime, that little notch there, tells me this is after the transformation. What's the next transformation we learned? Reflection. And with the reflection, you're always going to have a line of reflection, because depending on where the line of reflection is, the location of the transformed shape is going to be determined. The line of reflection could be x-axis, y-axis, it could be y is equal to x or y is equal to negative x. In fact, it could be any or all line, okay? But for the simplicity, we did a lot more on x-axis and y-axis. And it can be a vertical line or horizontal line or even diagonal lines. And here you have a line of axis, a line of reflection, line of reflection, that is x is equal to 4. Okay, so again, this is a vertical line. If you recall, x is equal to 4 is a vertical line, and the light blue flipped over to become the dark blue. And the third transformation that we just talked about is rotation. With rotation, you're always going to have a center of rotation and direction, whether it's going to be clockwise or counterclockwise, as well as the amount. It can be 90 degrees, it can be 45 degrees, 180 degrees. In fact, it can be any old degrees. It can even be a decimal degree. And so in this case, we have this image, the orange image, oh no, actually it's the purple image that became the orange image, because you can see the arrow here as well as the notation. Notice that C corresponds to C prime right here, and there's a little bar there, so that's a C prime. So purple became the orange, and it was rotated, and you can see the line, the angle. That's the angle. If you join any vertex to the point of rotation, and then another line to the point of rotation, another corresponding line, and the angle it makes, it's the degree at which it is being rotated by. Alright, so I want you to tell me in private chat, what is the transformation that is visible from this? Okay, can you tell which is the original, which is the transformed image? Which do we start off with, and which is after the transformation? And how do we know? Well, you might be thinking, oh, you know what? It kind of looked like it's just moved. Or it could even be a reflection because it's symmetrical. Well, how do we know which is which? Well, look at the letters. Here we have D and D prime. That means these 2 points are corresponding to each other, as do B prime and B. So B became B prime. And we know that which was original because the original ones do not have that prime notation. While it's after the transformation, you're going to have that prime or that apostrophe, that comma at the top. That's what we call prime notation. So B became B prime here. That means it's a flip along the x-axis. So ABCD is the original image. ABCD, the white image is the original. Then A prime, B prime, C prime, D prime is the reflected image. The blue one is the reflected image. And we use the prime, the sort of like a comma at the top on letters to indicate transformed location. And we read this A, comma, B, comma, C, comma, D, comma. And notice that it's not a comma, it's apostrophe as A prime, B prime, C prime, and D prime. And you should be taking notes on that. I want you to tell me this time, what is the transformation that you see? Well, I know that S and S prime correspond to each other, and R prime corresponds to each other. Okay? So knowing all of that, looking at the notation, can you tell me which one is the original? Original is always the one without the prime notation, without that apostrophe or the comma looking thing, right? So that means the blue is my original, and after transformation it became the green image. And if I asked you to describe the transformation fully, you're going to tell me it's reflection, right? And when you're talking about reflection, you need to always give the line of reflection as well. So you need to describe the line of reflection is the y-axis, because the distance from the y-axis for each of the corresponding line point is the same. Okay, what about this? What is the transformation that you see? Well, first of all, which one is the original? Looking at this, is it the black one or is it the blue one? The one with the prime notation is after the transformation. That means the black one is the original. Describe the transformation fully. Well, is it reflection, translation, or rotation? That's right, it's rotation around the origin of 180 degrees. If you're not really sure, you can always trace it and try to rotate it and make sure that it matches up exactly. Remember, it needs to match up exactly. And I can actually show you that by going to the slide here. Okay, here we go. Alright, so if I have this original here, this is my original. What happens after rotation? That means when I turn like this and match up the axis once, that's going to be 90 degrees. When I match up the image, turn it again 180 degrees, it's going to be, this is the image after when the original is rotated 180 degrees, and that is exactly where the new image is. So I know that that was rotation by 180 degrees. Clockwise or counterclockwise, it does not matter because they are the same thing. Okay? Alright, so then what's the transformation that is described here? Which is the original, which is the transform, which is the new? Well, the black is the original because we don't have the prime notation, and blue is the after the transformation. Describe the transformation fully. What sort of transformation is it? Is it translation, reflection, or rotation? It looks like it slid down or shifted. It just changed the position. The orientation is still the same, and the size is the same. It's just the position that has changed. So it is a translation, and we describe the corresponding points. So vertex W, how did the W change to W prime? It went down by 1, and it went 1, 2, 3, 4, 5 units to the left. So we describe it as left 5 units and down 1 unit, or down 1 unit, left 5 units. Does not really matter which order. Well, I suppose it's better to say left 5 units. What about this? Match the corresponding point. C became C prime. It went to the left by 2 and went up by 1. So it's a translation. Left by 2 units, up by 1 unit. Okay, and that is it for today.